All right, guys, so today we're going to start right here. I want to sketch this equation. Now, before I can sketch it, I need to know what I'm sketching. So when I look at this, I see an x term that's being squared added to a y term that's being squared. That means that we have a circle, and this particular circle is in radius center form. So looking at this circle, I can find that the center is the opposite. The opposite of the x term is positive 4. The opposite of the y term is positive 2. And then the radius is going to be the square root of the number on the right. So I have a circle with center 4, 2, and a radius of 8. When I sketch this, it looks like this. There's my circle, and you can see that I have my center of 4, 2 labeled on the graph, and I've gone 8 to the right, to the left, up, and down, and I've drawn the circle. And no matter how good or bad the circle is, I'm always going to label the radius with the radius value. Now, going back to the original equation here, this one that we have in radius center form, let's start again with that. Radius center form is very user-friendly, but it's not the only form that's out there. Another common form will divide everything on both sides by 64. And then 64 over 64 just equals 1. And you get x minus 4 squared over 64 plus y minus 2 squared over 64 equals 1. This is known as standard form. Yet another form drops the parentheses all the way down so that both the top and bottom are being squared. So you have x minus 4 over 8 squared plus y minus 2 over 8 squared equals 1. And this form is what's known as, or what I've seen commonly referred to as, professional form. As you can see with professional form, the center is still opposite, and the radius is the matching denominator terms. Professional form is the form that we're going to use most often. Now, unfortunately, equations for circles aren't always given in one of these three forms. There's another form that we need to work on, and so we're going to start again with our original equation, and we're going to build into the new form. So we have our original radius center form here, and the fourth form of a circle comes by squaring out these two terms. So we have x minus 4 squared, so we get x squared minus 8x plus 16, and then y minus 2 squared is going to be y squared minus 4y plus 4 equals 64. And then they rearrange the terms to get the squared terms together, x squared plus y squared. They get the plain old x and then the plain old y, so minus 8x minus 4y, and then they get all the numbers combined together as the final terms. So 16 plus 4 makes 20, but subtracting 64 gives us negative 44 equals 0. This right here is what they call general form of a circle. Equations will oftentimes start in general form or some mixed up, messed up version of general form. Here's what I mean. I can take these pieces and let's change this to x squared minus 8x plus y squared equals 4y plus 44. It's not general form exactly, it's a mixed up, messed up version of the original equation. Or they might say factor out the 4. And again, we have an equation that is again not in general form, but it's a mixed up, messed up version of the general form of a circle. So the question now becomes, how do we get from point A to point B? Ignoring the mixed up, messed up versions that we can pretty easily turn into general form, how do we get from general form into radius center form? Or further into, say, standard form or professional form? Before we answer that question, let's make sure that you recognize exactly what you're dealing with. We know this is a circle because we started with radius center form and we've manipulated it. We've changed the version. But looking at a given equation, you can always know that you're dealing with a circle because you have an x squared term plus a y squared term. and we haven't had to deal with it, but on the x squared and the y squared, the coefficients in front of those terms will match exactly. Now in this case, the matching coefficients are just 1. I'll show you how to deal with coefficients later, but for now, just know that those coefficients have to match exactly. Also, both your x squared term and your y squared term are positive. Now, if they were both negative, you could simply divide both sides by a negative, and you'll make them both positive. But if one's negative and one's positive, then you are no longer dealing with a circle. You're dealing with something that we will get to later. So the question again is, how do we get from general form to any of the other forms? Let's start with x squared plus y squared minus 8x minus 4y minus 44 equals 0. It's the same equation yet again. We need to get our x's with our x's, our y's with our y's, and our numbers on the other side. Once we've done that, we're going to group them. Now, just for a little bit, we're going to ignore the y's completely. We're going to pretend that the y's don't exist, looking only at the x's. If we look back at radius center form, we see that it is a perfectly squared version on the x term that we're dealing with. We have a perfect square on the x term. So we need to look at our x term and create a perfect square. We need to complete the square. So we're going to take 1/2 of that middle term, then we square it, and we're going to add that to both sides. So I have x squared minus 8x plus 4 squared added inside the parentheses, plus leave some room for the y's. We're going to come back for that. And then we have 44 plus 4 squared. Now we take the first term, last term, the middle sign, squared. We have our perfect square. So now we can look back, stop ignoring the y's, and instead ignore the x's and do the exact same thing for the y's. We need to form a perfect square for the y's. We need to complete the square. So we're going to go 1/2 of the middle term, square it, and add that to both sides. So we have y squared minus 4y plus 2 squared, and then again plus 2 squared. Then we take our first term, last term, with the middle sign, the whole thing squared, to create our perfect square. Now adding these numbers up on the right hand side, 4 squared is 16, 2 squared is 4, 16 plus 4 is 20, 20 plus 44 is 64. And right here you see that we have found our radius center version. And if we were only ever sketching circles, there would never be any need to go beyond radius center form. But we're actually going to work with a few different shapes. So we need to have a single form that we always go to, and that's our professional form. We are always going to take these shapes to professional form so that I don't have a different technique, a different idea for each different equation. It's the same idea for each equation. We take it to professional form every time. So to get there, we now divide by 64, divide by 64, divide by 64. We're going to drop our parentheses all the way down so the entire term is squared. And to get that term on the bottom, we're going to take the square root of 64. Again, drop the parentheses all the way down. So I have y minus 2 over 8 squared equals 1. This is professional form. And as you can see, our center is opposite, opposite, and our radius is the number on the bottom. Just like from radius center form, you could see that the center is opposite, opposite, and the radius is the square root of that number. Try this equation. See if you can get it to professional form all by yourself. We've got x squared plus y squared minus 4x minus 6y minus 12 equals 0. Now, remember, if I had wanted to, I could have started this in a different version. I could have given it as, say, x times x minus 4 plus y squared minus 12 equals 6y. I could have done any sort of mixed up, messed up version of this, and all you would have done is undo that messiness and get it to general form to start. So here we are at general form, and I'm going to get my x's with my x's, my y's with my y's, and my numbers on the other side. I group them, and I complete the square on each term. So 1/2 of 4 is 2, square it, and I'm going to add that to both sides. X squared minus 4x plus 2 squared plus, leave room for the y's, equals 12 plus 2 squared. Coming back for the y's now, I go 1/2 of 6 is 3, square it, add that to both sides. I get y squared minus 6y plus 3 squared, again, plus 3 squared, and I form my perfect square. So it's first term, last term, middle sign, squared, plus first term, last term, middle sign, squared, equals, adding these numbers, 2 squared is 4, 3 squared is 9, 4 plus 9 is 13, plus 12 gives me 25. Dividing by 25, dividing by 25, dividing by 25, I drop parentheses all the way down, I get x minus 2 over 5 squared plus y minus 3 over 5 squared equals 1. I can see that my center is opposite, opposite, it's 2, 3, and my radius is 5. Now let's pretend for just a second that this wasn't a 12 to start. Let's pretend that this had been a 38. That would make this a 38, that would make this a 38, that would make this a 38, and when we add 38 plus 13, we would have had a 51 here. So what do we do with the 51? Well, same as we did before. We divide by 51, divide by 51, divide by 51. So then on the bottom, I would have had the square root of 51, which is, I don't know, it's just the square root of 51. Again, I would have had just the square root of 51. So that means my center was 2, 3, and my radius would have been the square root of 51. How big is the square root of 51? Well, I know it's a little bit bigger than the square root of 49, which is 7, so it's just a little bit bigger than 7. And when I draw the circle, I would draw a radius that's just a little bit bigger than 7, and I would label it as the square root of 51. Now, notice real quickly, for problems like this, I'm actually allowed to have the square root on the bottom of a fraction, but I'm not allowed to have a square root on the bottom of a fraction. Stick with me here. Pretend it was a different problem and pretend somehow we got x minus 2 over rad 2 squared. That would be perfectly fine. But if we had x minus 2 over 1 over the square root of 2, that would not be okay. This denominator would need to be rationalized to rad 2 over 2. Because of the way we use professional form, we keep the top and the bottom separate in our minds. So I'm allowed to have a radical on the bottom. I just can't have a radical on the bottom of the bottom. Now let's say we want to sketch this equation. I know I'm dealing with a circle because I have an x squared plus a y squared, and they have matching coefficients of positive 4. But this problem is different because we actually have coefficients other than 1. Now in theory, you could divide the entire problem, both sides, by 4, and that would work out just fine. I would get rid of my coefficients, I would have just an x squared plus a y squared, and I could go from there. But depending on the other numbers in the problem, you might end up with some pretty nasty fractions. Plus, based on where we're going with these problems, we need to build the skill set of what to do if we can't divide away the coefficients. So here's what we can do. Starting again, we treat it the exact same as we did the other problems. Let's get our x's with our x's, our y's with our y's, and our numbers on the other side. And then we group them. Now, ignore the y's, pretend they're not there. We can't complete the square on the x with this 4 sitting here, but we also don't want to divide away the 4. And so what do we do with it? Well, we can factor out the 4 and just hold on to it on the outside. Now, with the 4 sitting on the outside, we can complete the square on the x's. So I'm going to say 1/2 of 4 is 2. Square it, and then I'm going to add that term to both sides. So I have 4 times x squared minus 4x plus 2 squared plus, leave some room for the y's, equals negative 34 plus, now here's the interesting part, I didn't just add 2 squared on the left. Because the 2 squared is inside parentheses, technically speaking, it's being multiplied by 4. That 4 outside the parentheses is being multiplied by the 2 squared. So when I add the 2 squared to the right, I don't just add plain old 2 squared, I add 4 times 2 squared. Let's look at the y's. It's going to play out pretty much the same. Let's factor out the 4. We get y squared minus 6y. Now we're going to complete the square on the y's inside parentheses. So I'm going to say 1/2 of 6 is 3. I'm going to square it, and now I'm going to add that to both sides. So I have 4 times y squared minus 6y plus 3 squared. And then when I add the 3 squared, I don't just add the 3 squared. I add 4 times 3 squared, because the 4 on the outside is technically multiplied times the 3 squared also. Now I can form my perfect squares. I have 4 on the outside, first term, last term, middle sign, squared, plus the 4 on the outside, first term, last term, middle sign, squared, equals, and we need to crunch all these numbers on the right. So 4 times 4 is 16, plus 4 times 9 is 36. That ends up being 18. So now we keep going. We divide by 18, divide by 18, divide by 18. And you might at this point want to just reduce your fractions. But reducing fractions still leaves us with a 2 on the top. And professional form has no coefficient on the top. We have to completely get rid of that coefficient on the top. So instead of thinking in terms of reducing fractions, think instead as what I do to the top, I need to do to the bottom. So I need to get rid of that 4 on the top. So I'm going to divide the top by 4. And I'm also going to divide the bottom by 4. That's going to give me x minus 2 squared on the top. And that's going to give me 18 over 4, or 9 over 2 on the bottom. Again, what I do to the top, I do to the bottom. So I'm going to divide the top by 4. I'm going to divide the bottom by 4. So on the top, I have y minus 3 squared over 18 over 4 reduces to 9 over 2, which equals 1. So now I'm going to drop my parentheses all the way down. So I have x minus 2 over, I need to take the square root of 9 over 2. So the square root of 9 is 3. The square root of 2 is, I don't know, the square root of 2. And I'm doing well, except I now need to rationalize this denominator. So what I'm going to end up with is x minus 2 over 3 rad 2 over 2 squared. Going back to the problem, I have plus, dropping parentheses all the way down, y minus 3 over 3 over rad 2. Now I need to rationalize that denominator also, so I get y minus 3 over 3 rad 2 over 2 squared, which equals 1. Now my center is going to be opposite, opposite. My center is 2, 3, and my radius is 3 rad 2 over 2. But when it comes to sketching 3 rad 2 over 2 is a little bit tricky because I don't know exactly how big that is. Having that 3 there actually messes up my approximation a bit, so I don't want to approximate with that 3 there. Instead, I'm going to look back to this 9 over 2 term when I first took the square root. If I think of 9 over 2 as a decimal, 9 over 2 is 4.5. It's 4.5. So I'm actually dealing with the square root of 4.5. I have the square root of 4.5. The square root of 4.5 is just a little bit bigger than the square root of 4. So when I sketch 3 rad 2 over 2, it's going to be the exact same as the square root of 4.5. So I'm going to sketch something that's just a little bit bigger than 2. When most people hear the word cone, they think of the more traditional interpretations of the word, but mathematicians have a different idea. They use what's called a double-napped cone. And the idea is you have an axis and then a line. And this line spins around this axis anchored at a certain point. Now, as this line spins around, you can imagine what's happening. In fact, you can do it with the pen or pencil in your hand. you get a shape that looks something sort of like this. That's the basic look of a double napped cone. It's essentially a two-sided cone. Now, if I take this cone and I chop it into different sections, I have what are called conic sections. Now, we've already dealt with a conic section before, we just didn't call it that. We dealt with a parabola. You get a parabola from a cone when you cut off one edge of it like that. If you look at the resulting shape, and look at that shape flat on, you'll see a parabola there. Again, if I cut my cone directly across and look at the resulting shape, you'll see a circle. If I chop higher on the cone and higher on the cone, you'll get a bigger and bigger circle. If I chop lower, that circle's going to get smaller, and vice versa for the bottom. If I chop higher and higher, that circle gets smaller, and if I chop lower, that circle gets bigger. Let's look at another problem real quick. If we've got x squared plus y squared plus 8x minus 6y plus 25 equals 0. See how that plays out. You get your x's with your x's, your y's with your y's, your numbers on the other side, and group them. Now I'm going to complete the square. 1/2 of 8 is 4. I'm going to square it, then I'm going to add that to both sides. Come back, complete the square on the y's. 1/2 of 6 is 3. 3 squared, add that to both sides. And I get x plus 4 squared plus y minus 3 squared equals, this is 16 plus 9, that's 25. 25 minus 25 is 0. Interesting. Now, if I'm thinking professional form and I go divide by 0, divide by 0, divide by 0, that math doesn't make sense. We can't divide by 0. What we have here is what's called a degenerate circle. It's a degenerate circle. It's a good circle gone bad. And the basic idea is that we are chopping our cone directly through the center, and we're ending with a single point. When you have the squared terms of a circle equaling 0, you have a degenerate circle, and all you sketch is the center point, the opposite. You would sketch only -4, 3. Your graph would look like this. 1, 2, 3, 4, 1, 2, 3, right there. It's a degenerate circle. You sketch only the point. Now let's pretend that we had a problem where after completing the square, we ended up with a negative number. Let's think for a second. Is it possible for a squared term plus another squared term to equal a negative number? Something that's squared is positive, and if I add another positive, there's no way I'm ever going to get a negative number. This math is not possible. This is also called a degenerate circle, except in this case, there is no graph. When the squared terms equal a negative number, there is no graph, and all you would write is no graph. Now finally, what would we do for an equation like this? I know it's not a circle because while I have x squared plus y squared, my coefficients don't match. And while I may not have told you what it is quite yet, we're going to go ahead and do the exact same process on this equation. So let's get our x's with our x's, our y's with our y's, and our numbers on the other side. And we group them. And this is why I didn't want the idea of just dividing by the coefficient to be the only idea that you had. Because if we divided the whole thing by, say, 25, that wouldn't help us with this 9 over here. We would still have mismatching coefficients. So we're going to pull the coefficient out, factor the coefficient out, and then we're going to complete the square on the x's. 1/2 of 8 is 4, square it, add that to both sides. So I have 25 times x squared minus 8x plus 4 squared plus, leave a bit of room, equals negative 184 plus, and I'm not just adding 4 squared, I'm adding 25 times 4 squared. Now I come back, I'm going to factor out the 9 and complete the square on the y's. 1/2 of 2 is 1, square it, and I add that to both sides. And again, I'm not just adding 1 squared, I'm adding 9 times 1 squared. Now I form my perfect squares 25 times first term, last term, middle sign, the whole thing squared, plus first term, last term, middle sign, squared, equals, and when I do the math over here, I add those numbers up, I get 225. So I'm going to divide by 225, divide by 225, divide by 225, and I need to get rid of the coefficient outside the squared term. And instead of thinking of it as reduce the fraction, I'm going to think of it as what I do to the top, I'm going to do to the bottom. So if I divide the top by 25, I divide the bottom by 25. If I divide the top by 9, I divide the bottom by 9. So I have x minus 4 squared over 225 divided by 25 is 9, plus y plus 1 squared over 25, which equals 1. I've taken this equation almost all the way to professional form. I'm going to drop those parentheses all the way down, and I get x minus 4 over 3, the whole thing squared, plus y plus 1 over 5, the whole thing squared, equals 1. And without even knowing what this shape is, you can tell me what the center is. The center is opposite, opposite. My center is 4, negative 1. But the bottoms are different. There's no radius on this because, again, it's not a circle. This shape is called an ellipse. Notice, ellipse has 2 L's. An ellipse is what you get, come on back, when you cut through a double-napped cone diagonally, but don't go off the end. If you look at what I have here, I have a shape that looks kind of like an oval. Again, if I cut through a double-napped cone on the diagonal, I end up with an oval shape. If I cut through on the diagonal, I end up with an oval shape. That is what we call an ellipse. And so, coming back, our ellipse does not have a radius, but rather it has what we call a horizontal displacement and a vertical displacement. The horizontal displacement is the number that you find on the bottom of the x term. The x-axis goes side to side. The x-axis is horizontally oriented, and so the horizontal displacement is under the x term. The vertical displacement is on the bottom of the y term. So to sketch this, I'm going to go to 4, negative 1, put a point there. I'm going to label it as 4, negative 1, and then horizontally, I'm going to move 3 to the right from the center. So I'm going to go 1, 2, 3, put a point there, and then I'm going to go the other direction. 1, 2, 3, put a point there. Then vertically, I'm going to move 5. So I'm going to go 1, 2, 3, 4, 5, put a point there. And vertically again, I'm going to go 5. 1, 2, 3, 4, 5, put a point there. So I have my target points laid out, and now I'm going to connect the dots. La, 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 la. I'm going to try to make it look like an oval. I'm going to do the best I can. Big dots fix everything. And then I can label my horizontal displacement as 3 and my vertical displacement as 5. Just like a circle, sometimes a good ellipse can go bad. Imagine our double-napped cone being chopped on the diagonal directly through the center. That's going to be a degenerate ellipse. We're going to sketch only a point. Now imagine I swing and I chop and I miss the cone completely. That's also going to be a degenerate ellipse that has no sketch, no graph. Degenerate ellipses can be found right here. If we have the squared terms, and then we did the math and got 0, that's a degenerate ellipse where you sketch only the center. You'd sketch 4, -1. If you had the squared terms, equaling a negative number, that's not mathematically possible. You can't have a squared term times a positive number plus another squared term times a positive number ever equal a negative number. That can't happen. So in this case, there would be no graph. All right, guys, I hope that made sense. If you have any questions, let me know.